In this video, we're going to be going over a couple of questions that I prepared. There's going to be this video, which is part 1. It's going to include the first 2 questions, and then there's going to be another video, part 2, that's going to include the second 2 questions. So to start off with, we're given this situation here where we're supposed to consider this quadratic equation, and then we have to find the vertex, the x-intercept, and then the y-intercepts. So to start off with, we're going to go ahead and there's a couple of ways to find the vertex. One of them is to start off by taking the 2 x-intercepts of the parabola, and then you kind of just split it in the middle, figure out what that x value is in between that, and then you just figure out what the y value is at that x value, and then you've got your vertex. But since in this problem, he's asking for the x-intercepts later, and I don't really have them right off the bat, I'm just going to show you another way of doing this. So basically, you can use a formula x equals negative b over 2a. And so when I plug in all that, b is negative 6, and then a is 1, right? So that gives us negative 6 over 2 times 1. And then when I solve that, that gives us that x equals 3 at the vertex. So then I just need to use this x value for the vertex and plug it in to figure out what the y value is when x is 3. So to do that, I just rewrote our equation from up here. So the original equation was f of x equals x squared minus 6x. So here I just plugged in, for the x's, I just plugged in 3's. So y equals 3 squared minus 6 times 3. And when you go through that, 3 squared is 9, and then 6 times 3 is 18. So that's 9 minus 18. 9 minus 18 is negative 9. So those are our x and y values for the vertex. So I'm just going to rewrite them properly at the top with our x and y values. And here I actually made a mistake. It's supposed to be 3 and then negative 9, not 9. So that's a problem. But then moving on to the next problem, it says the x-intercepts, find the x-intercepts. So to find the x-intercepts, you just have to set y equal to 0. So what I did here was I just rewrote the equation again, so y equals x squared minus 6x, and then I'm factoring it. So I took out an x, and then I'm multiplying that by an x minus 6. And what you can do with that is set it equal to 0, and therefore x has to equal 0, right? Because that's one of our factors, so x equals 0, or x minus 6 equals 0. So when you put x minus 6 equals 0, x equals 6. So our 2 x values of the x-intercepts are x equals y and x equals 6. And then we're just going to have to put that correctly with the y as well, because when he says x-intercepts, he wants a point, which includes first, it's like a coordinate, so it has to include the x and the y value. So the first one is 0x and 0y, and the second one is a value of 6 for x, and a value of 0 for y. Because again, the definition of x-intercepts is that y equals 0, so that's a must. And then moving on to the next one, it's about finding the y-intercept. So to find the y-intercept, you just have to set x equal to 0. So that's fairly simple. You just take the equation from above, which is fx equals x squared minus 6x, and all you do is for the x's, you plug in zeros. So y equals 0 squared minus 6 times 0. And that just gives you y equals 0. So our point is, again, 0, 0 right here. Then moving on to this next question, I decided to move on to some printer paper because I thought it would look better, and it does. But here we're being asked to factor a higher degree polynomial. So because it's a higher degree polynomial, you can't do it the way we've been doing quadratics so far. But I'm going to show you how to do that with long division. So basically you have to figure out what p and z are. So p is the last number all the way on the right, and in this case it's 20, and then z is the coefficient for the highest degree, or the highest, I forget the word, but it's basically the highest, like the x with the highest, raised to the highest number. And in this case that would be x cubed, and the coefficient of that, z, is just going to be 1. So we found our p and z. All you do is put p over z, so that's 20 over 1, which is just 20, and then from there you just figure out the factors of 20, and the factors are plus minus 20, plus minus 10, plus minus 5, plus minus 4, plus plus minus 2 and plus minus 1. So once we found those factors, we can go ahead and start trying them out. I suggest starting from the smallest one, which is going to be 1. Try the positive one, then try the negative one, and then move on to the 2 if those don't work. So first we're going to try the positive one, and the goal is for us to plug this number in and it's equal to 0. So I went ahead and I plugged in 1 for each of the x values, and that gave me 24. So that is not going to work. So I went ahead and I decided to try negative 2. So trying negative 2, I plugged in negative 2 for everything, and I did get 0. So that's one of our factors. Now here I actually made a little mistake because I got a little confused. So just ignore this little stuff on the right. But the idea is that if x equals negative 1, then our factor is x plus 1 equals 0. So you can write that out just to make sure, but ignore what I wrote here because it was completely the opposite of what it should be. So our factor is, because, I'm just going to repeat that again, so because x equals negative 1, our factor is x plus 1 equals 0. So I used the factor x plus 1 here. And I wrote that on the outside of the division sign, and then on the inside I wrote x cubed minus 8x squared plus 11 plus 20. So it's basically just our original equation from up here. You just write it on the inside, and then you write the factor that you found on the outside. And then you go ahead and you start your long division. So basically, so here I decided to start with an x squared, because the idea is you want to cancel out this x cubed. And so you multiply an x by an x squared, and that gives you an x cubed that we can use to cancel it out. So I wrote an x squared up here. So we're going to multiply the x squared by the x, and that gives us an x cubed, which I've written below. So x squared times x equals x cubed. X squared times 1 equals x squared. So I wrote them both below. And what's happening here is that they're being subtracted. So I wrote a subtraction sign on the outside. And what I like to do is I like to kind of take this negative and bring it in. And how I do that is, you can do it any way you want, but you have to be careful, is I like to cross out the sign that was there and then write the new sign on top of it once I've incorporated the negative sign. So this one used to be just x cubed positive, so I put a negative sign on top to show that incorporating this negative on the outside, it is now negative. And for this one, it used to be positive as well, but incorporating the negative from the outside, it's now negative. So you can do this any way you want, just be careful, make sure you don't lose track of your signs. So once you do this, this is perfect, because then the plus x cubed and the minus x cubed can cancel out with each other. And so that's what I've done here. I crossed them out, and then I just did negative 8x squared minus x squared, which is just negative 9x squared. And then I also brought down the 11 from up here, so you should make sure that you keep bringing it down. So I brought down the 11. Oh, this should be an 11x, by the way, because this is an 11x right here. But I fixed that in the next step, as you'll see. So again, I had brought down 11x, and what I figure out is that in order to cancel an x with a 9x squared, I need to multiply that by a 9x. So again, 9x times x is going to give us something that'll cancel with the 9x squared. And so I show that below, that 9x times x is 9x squared, 9x times 1 is 9x. And so I wrote those below. Now the sign, this is a little bit tricky. So remember how we are subtracting everything on the outside? Well, in order to subtract something, we want it to be positive, because this thing right here is negative, right? So we want this to be a positive. So the best way to do this is to make it a negative. So it's basically a negative sign on something that's already negative, because then it will become positive and it will cancel out. So I just included a negative up here. So this is x squared minus 9x. And so that gives us a negative 9x squared minus 9x, right? But we have a negative on the outside, so when you multiply this negative in, I get to cross out my previous signs and they become positive, both of them. So that's why I like to have like a system of I show myself if I've incorporated the negative from the outside yet. And this is perfect because negative 9x squared can cancel with the positive 9x squared. And so I'm going to go ahead, cancel that. And then we're left with positive 11x plus 9x. So that's just 20x. So I brought that down. I also brought down the 20 from the top over there. So make sure you keep bringing your next thing down as you do this division. So then from there, it's pretty easy to figure out that if you just multiply this thing by 20, you get that, which is great because then they can cancel out. So I just included a 20 up here. 20 times x is going to be 20x, and then 20 times 1 is just going to be 20, so that'll work out. So that's exactly what I did down here. I just did, this is 20x and this is 20, and there's a negative on the outside, remember? So then I can figure out what my signs on the inside have to be. And since this one is positive, I need the new one to be negative. And so I'm just going to leave this as a positive. So I'll change this and make sure that this is a plus. So here I had just made sure, I had just put my plus in here. So it's x squared minus 9x plus 20. And then, so multiplying these by plus 20 and then bringing the negatives through, you find out that you can cancel everything. And there's a remainder of 0. So that's kind of like, that's kind of the other factor. So now I started my work on the left of the page over here. Our factors are x plus 1, which we took from here, and x squared minus 9x plus 20, which is the result from the top of our long division. So then you have to, this is just a quadratic now, so you can factor this pretty easily. So I'm just going to do the previous method that we learned. I put an x and an x, and then I had to figure out what multiplies to be positive 20 but adds up to be negative 9. And so if you multiply a negative and a negative, that's going to give you a positive. And if you add a negative and a negative, it's going to give you a negative, right? So I think that it's going to be two negative numbers. And the two numbers that work out are negative 4 and negative 5, because negative 4 times negative 5 is positive 20, which is good. And then negative 4 minus 5 is negative 9, which works out as well. So those are the two factors of the quadratic portion. So now we kind of have three factors. We have the x plus 1 from here, and the x minus 4 and the x minus 5. So that's our answer for the for this question. Now, if he had asked you for roots, because the beginning of this question asked for the factors, but if he had asked for roots, you should just solve it. So you should just like take your x minus 4, set it equal to 0. So one of the roots is when x equals 4, for example. For this one, like x equals 5, set it to 0. So x is equal to 5, right? X minus 5 equals 0. So x is equal to 5, and that's a root where x is equal to 5. And then you would also have to include the y value as well.